if you wanted cosine x e to the cosine of x times e to the sine x, normally you would put parentheses like this. But sometimes you get sloppy, you leave out the parentheses, and it could get a little confusing. So if you want to do it this way, be sure to put the parentheses in there so there's no confusion. Alright? Remember, this of course does not equal that. Alright, they're not the same thing. Okay. Now, the antiderivative of e to the u du is e to the u plus c. That only makes sense. The derivative of e to the u is e to the u, so the antiderivative would be e to the u, and don't forget your constant of integration there. But again, this is a whole family of functions, depending on what c is. C is just any real number. So this antiderivative has many, many different solutions depending on c. Okay, but if you take the derivative of all of these, no matter what c is, the derivative of a constant is 0, so you get the integrand back again. The derivative of e to the u plus c is just e to the u. Alright, so let's take another example of a definite integral. This time we've got the integral from 0 to ln2 of e to the 3x dx. Alright, we'll do a u substitution on this. So we'll let u equal 3x, and then du is 3 dx. And then let's change the limits of integration. U of 0 is 3 times 0, of course 0. And u of ln2 is 3 times ln2. And you can use the power rule in reverse. That would be ln of 2 cubed, which is ln of 8. Alright. So now, what we have then is, going back here, the integral here, we don't have 3 dx anywhere in the original integral, so 1/3 du is equal to dx. So now 1/3 du covers the dx, and e to the u covers the original integrand function there. So what we have then is a new integral here, 1/3 integral of 0 to ln 8 e to the u du. And that equals 1/3 e to the u, going from 0 to ln 8, and that's 1/3 e to the, let me bring the 1/3 in front here, 1/3 e to the ln 8 minus e to the 0. And e to the ln 8 again is just 8, so this is 1/3 of 8 minus, and e to the 0 is 1, so 8 minus 1, or 7/3. 7/3. Alright, so that's your solution. Now don't give me a decimal approximation on that, alright? If you use a calculator, you can use calculators to take definite integrals, and they will give you the decimal approximation of 7/3, but I don't want to see that. Okay. Let's do another example. We've got integral from 0 to pi over 2 of e to the sine x cosine x dx. So e to the sine x, the sine is in the power of e, and then cosine x is outside of e there, and dx. So we'll do a u substitution. Let u equal sine x, and then du is cosine x dx. And then u of 0 is sine of 0, which is 0. U of pi over 2 is sine of pi over 2, and that equals 1. So now we have the integral from 0 to 1 of e to the u du, which is e to the u evaluated from 0 to 1, and that's e to the 1 minus e to the 0, which is e minus 1. And that's your solution. Okay, let's do one more example here. I have an initial value problem. Let's take e to the y dy dx, or e to the y prime if you wish, dy dx minus, or rather equals 2x. So let me separate that there. And let's assume that x is greater than square root of 3, and also y of 2 is equal to 0. So this is an initial value problem. Y of 2 is 0, that's your initial value, and you're going to use that to solve for the constant of integration. Your objective is to find y, as usual. This is a differential equation because you have a derivative in this equation, first derivative. Alright, so you integrate both sides. Alright, now the antiderivative of e to the y dy dx is just e to the y. In other words, the derivative of e to the y is e to the y dy dx, so the antiderivative of this would be just e to the y. So what you have then is e to the y is equal to the integral, or the antiderivative of 2x, which is x squared plus c. Alright, now from the initial condition, when y is equal to 0, x is equal to 2. Alright, so you've got e to the 0 is equal to 2 squared plus c. Alright, and so c then is equal to 1 minus 4 or negative 3. So what we have then is e to the y equals x squared minus 3. And again, we want to solve this for y. That's our objective in these differential equations. So you do that by taking ln of both sides. Ln of e to the y equals the ln of parentheses x squared minus 3 close parentheses. Alright, and so ln of e to the y is y. Y equals ln of the quantity x squared minus 3. Now, this explains why we have the restriction on x in the beginning. X must be greater than square root of 3. The reason being, then that would make this ln function defined, right? So if x is greater than the square root of 3, right there, when you square it, you're going to have something greater than 0 inside that ln. Alright, and of course, ln's domain is all x greater than 0. Okay, so let me give you a homework assignment on this section, section 6.3. That's going to be 17 to 63, every other odd. EOO. Alright, so there you go. Thanks a lot for your attention.